All right, so let's solve this radical equation. Here I have the square root of 3y plus 8 equals 2. So I need to isolate my radical here. It is not isolated yet. There's a plus 8 on the same side. So I'm just going to subtract that 8 away from both sides. And now I'm left with root 3y equals negative 6. Now it's isolated. I'm going to square both sides. Squaring the left will cancel out the radical and the square. So I'm left with 3y equals negative 6 squared. Negative 6 times negative 6 gives me a positive 36. Now I'm left with something linear. Divide by 3, divide by 3, and y is just 12. Seems very basic, very simple. We got to check it. I know it's like, oh, it was so quick and easy. Let's just say it's 12. No, we can't. We have to check it. All right. So the square root of 3 times 12 plus 8 equals 2. The square root of 36 plus 8 equals 2. The square root of 36, 6 plus 8 equals 2. I'm pretty sure I know where this is going. 14 equals 2, which is not equal to. What does that mean? That means that our solution, our one solution, we only got one this time, is extraneous. That means even though we got a solution, it doesn't work in the equation. And we could leave it like this and say that is what it is, but let's briefly talk about, well, why? All right, what part of this makes this happen? Why does it happen sometimes and sometimes not? Well, if we were to go back to this line right here, I'm going to rewrite that line here. All right. We originally had the square root of 3y equals negative 6. So what that means is if I take the square root of something, I need it to equal negative 6. That is impossible to happen. We cannot take the square root of something and get negative value. So that means if at any time you're left with a radical and it equals a negative value, there's going to be no real solutions, no real numbers that will make that true. So that is why when we got 12 and we plugged it back into the original equation here, it just did not work.